Hey guys, okay, I'm back. Here we go. I got the Himawari-8 up, latest run, around 1400 UTC. This is 11 p.m. Australia time, Melbourne time. Still got the same object coming through, just like yesterday, or on the last several days, since the 17th when I first made a video on it, first discovered it, about 1340, so about 1040 Australia time, Melbourne. Starts illuminating some type of reflections coming off of something over here by this Himawari-8 weather satellite, which is in geosynchronous orbit around the planet, somewhere around 22,236 to 241 miles. These satellites go round and round. Weather satellites and a bunch of other satellites, I'm sure, GPS stuff and all that. And these GOES 13 and 14, which provide us with all this data that makes up these ISWA magnetosphere simulations. I checked these runs out, pretty much no missing time, maybe 10 or 20 seconds here or there. Still got the huge electron bleed into the, well, not so much huge on this one, like we saw the last two videos. Not as red, but we got a splash there and a splash there. These are the low energy electrons. I think the high energy electrons are coming up quite a bit higher. And as I mentioned this morning, you got the blacks and the purples showing up again. But not only that, I think it's so high, these counts, that where you see this white, well, that's inside the faux bow shock, which is not showing up a lot for me here. There it is. See the bow shock? It's trying to ward off all this backside pressure from Nemesis. I think the electron counts are so high, it just simply went white. And this is the highest one I can find anyway on ISWA, on anywhere really. I think I did see mention of one that had 4,500 or 4.5 MeV, 4,500 KeV. But I don't think it would make that much difference, so I didn't really hunt for that. Anyway, we got the MLSO today, and looks like they sanitized this run, but we're still seeing some of the stuff shooting across. And there's some big ones here, as you might notice. There they are. I don't know where that one went. I guess what I think's happening is all these electrons bleeding in are really pretty much obscuring the heck out of this photograph, and you can see it even more on this one. This is a different camera filter. Still got the gamma, but as you can see here, and we've never seen it look like this before. We're getting a lot of similar to a lot of, I showed you on ISWA with that high electron count. It's just like whiting out, but in this case it's blacking out. So that's what's going on around the planet. Not good. One of my viewers this morning posted a link to this dude's channel, 40-meter band interference, and he recorded this. I guess he's a ham radio operator. And that must be one of the ham bands, but he said if you listen to the video, he wiped out, this interference completely wiped out his entire 40-meter high frequency band. Then after a few minutes also started affecting the 30 meter band. So I mean, I think it's just a reflection of all these high electron counts. Schumann resonances have been off the charts lately, including right now. See, this thing's climbed way up to 18 and maybe higher. These are a couple different charts. I'm not sure exactly how to read these, but I know this one, and it doesn't look good. So if you've been feeling kind of crappy as of late, which I have, normal frequency 7.83, I know that much. I don't know these numbers. It's hertz local time, there's 8.22. So it's definitely above. I think these are, some of these places are read in different locations on the planet, so you get different frequencies, different locations. So here's the image again. And I don't know what else it could be, guys, but a planet, and we get the white reflecting beam. So whatever it is, that's a sun simulator reflecting off of it. And you see the ones I make in the morning on the Ghost 16, you only get the one beam. But on this one you get more light showing. So must be a little bit closer to this satellite maybe, I don't know. But they got the whole thing pixelated out, as you can see. So they're hiding it. So it can't be good if they're hiding it. I mean, I don't know, can't really put a finger on why it seems to be staying in the same spot, although I think maybe, I don't know, it might be getting closer to these satellites because these beams have been getting a little bit wider, in my humble opinion. So you just make sure you click natural color if you go in and do this yourself, and then put it up to 60 images. That's the most you can get on here on this Colorado State EDU site, and put it on the lowest time step, which that will be the slowest one for you. Then just drag the speed way down and you can let it play. I'll let it play through one time, then we'll go look at something else. Here she comes. Womp womp. Before I lose you, I know you probably don't watch this whole video. Some of you, I don't know. Maybe you do. Here's Willa. And Willa still is not a hurricane. She's definitely a tropical storm. But top wind speed I can find in here is what? 54. 54. 54. That's it. And Vicente, that shouldn't even have a name. It's supposed to be up at least 36 mile per hour sustained winds to have a name. So I mean, it's just crazy what they're doing, guys. And we'll keep updating that. Here's the last 3 days on Discover. That's out at the L1 Lagrange point. Here's the density. I think I showed you in a few videos back when the title was solar wind densities 5 times normal. Normal is 4 to 6 atoms per cubic centimeter. So you can see it's come down, but yesterday it went back up again. So that's like triple there, at least. And it went back up over 30 again. So it's like 5 times close to it, give or take. And then it's on the way back down again. As you can see here, solar wind speed came up a little bit last day or so, but it's still below normal. Normal is 400 to 700 kilometers per second. So here's ACE. This is the last 24 hours. Here's a 5.5 hour gap here. Then we got a little, looks like a 1 hour gap. So there's some objects up there that are blocking the solar wind stream in front of the ACE satellite, which are not being able to collect data. And that's reflected there in the 3-day thing. And the densities are different too than on the GOES. And as you can see on the Discover, we have no gaps. So that ham radio one I showed you where the whole band got wiped out at the 40 meter range and in the 30 also. This is Mary Cakesor. She's the one who provided that link, so it's on this video here when I put up this morning. So here's that Lagrange point 1 where the ACE and the Discover are parked, reading all the sun, or no, there's parked here, I'm sorry. One right here, that's the Earth. Anyway, it's 930,000 miles in front of the Earth, and they're both parked out here in order to give us an early warning on stuff coming from the sun, so that maybe they can dial back the satellites or harden them up or whatever they do. So as you can see with the gaps on the ACE and none on the Discover, and some of the solar wind densities being different, that I would say there's some objects up here that are near ACE and aren't near the Discover. That's my theory anyway, and I don't see how else it could be any other way. So here we go. I'll let this run through. Take a look at it. And that's about it, I guess. I don't know. Leave some comments below if you want me to cover anything else. Make sure you check the description box below the videos. I got most of the links in there that I use in these videos. And well, God bless, guys. Peace, and I'm out.